My name is Forrest Alvarez. This is the salt formulas and states presentation, obviously. So let's get right into it. So when I was originally putting this together, I kind of thought what I wanted this overall idea to be of the presentation, right? And this is kind of what it ends up being, right? So to me, this comic has always meant that regardless of whether you want to come explore this idea and you kind of want to push what's going on, time is going to move forward. I'm still going to be exploring it and working on it, and other people are as well. So if you don't want to, that's cool, but you're not going to really have a choice going into the future. So that was the big thing that I kind of wanted to get across. So that leads into this idea that formulas are the evolution of salt states, right? Which is kind of a bold thing to say, but they really are the future of salt. When you look at it from a development point of view, or you're somebody who's writing a lot of states, when you look at formulas, you're really seeing what's coming in the future and what really makes sense to our end users and to other people. All right, so let's start by just taking a look back at salt states. Before I get into this, so how many people are currently writing salt states for work? So pretty much everybody? Okay, you don't count. So how many people are currently writing formulas? A couple people? Well, you guys don't count again. So how many people know what formulas are? Okay, cool, so we have pretty good spread, great. So salt states themselves, we know, are really the core of salt, right? I mean, if you're doing anything legitimate with salt, you're gonna be using salt states. They range from really basic to extremely complicated. So we can have something as simple as, hey, install this package and start the service, to some crazy data where you're saying, okay, if it's this specific subnet, drop this pillar data in, and then pull this other grain variable. And it gets really confusing as to what's going on, right? So they have a lot of flexibility, which is something that makes them super, super powerful and something that's really cool when we look at them. They're primarily used for provisioning and deployment. I mean, if you're not using them in that way, I would like to talk to you to see what you are exactly doing with them. But that's the main thing that you're going to be doing. You know, we're not really using execution modules to provision systems or do any kind of work along those lines. You're going to be writing states when you're trying to get more advanced and you're really trying to make things happen. All right. So to continue off the refresher here. Salt states are pretty simple, right? The syntax is pretty straightforward. If you can write YAML or you can read YAML, which is really simple to do, then you're pretty much set to go with writing salt states. That's something really important to get the idea across. We've seen a lot of salt states already. If you guys were here yesterday, we saw some salt states this morning in the keynote. And it's really easy to understand what exactly is going on there. One of the things that people don't focus on as much, though, when they are writing salt states, however, is this idea of a modular focus, right? They're using everything in a single state, or they're really putting a lot of data in there. So maybe they're doing package installs and then a bunch of configuration files or application configuration in a single location. And that's one of the big things that people are having a hard time getting going with, that I need to make this as modular as possible so that I can reuse it in as many places as I possibly can, or allow other users in my organization to continue reusing it. And they're really easy to use. That's one of my favorite things about states. You can go from not knowing what's going on with salt to being ready to rock with salt states in about 20 to 30 minutes, depending on if you've used config management before, how fast you can read through the docs, and that sort of thing. So if we take a look at just a really quick example state, right? This is just Nginx. Okay, we're gonna, we have the package, we're gonna install it, and then we have the service, which we're gonna make sure is running. We're gonna enable it on the system, and then every time this state runs, we're gonna reload it. So this is really simple to see. We've got things indented a few spaces here, and it's very easy to understand what exactly is going on and what's gonna happen when we run through this. So if we take a look at the state directory structure itself, right? So the previous example was this srv salt nginx init.sls. Now in that context, the init file really makes sense because you're only doing one thing in there, right? You're starting the service. You can't run nginx without that. Obviously, you're not going to have an nginx minion that doesn't have any sort of nginx services on it versus a secondary server. But when we look at something like MySQL here, so the MySQL examples, they don't have an init file, right? What do we have inside of MySQL that would be used across the server regardless of what it was being configured for? Not a whole lot, right? We're either going to have a client MySQL server where we're going to be connecting into some sort of instance, or we're going to have a MySQL server itself. If we had all this crammed into the init so that the server and the client were getting installed, we'd really lose a lot of functionality because somebody like this might not be able to use it, or they might not be able to get their app up and running because they say, well, I don't need the client, I just need the server, or vice versa. So once again, we come back to a really modular idea there that we want to spread things out, we want to break things out as much as we can so that we can reuse it as much as possible. So I talked a little bit earlier about how salt states can become complex, and we've all seen this picture on the right, this really bad data center that just, if you've ever worked in a data center, just makes you cringe really badly. And that's one of the things that we want to avoid. So here is where we're basically making an OS agnostic state, right? This is Apache. So we're going to be installing the Apache package, and then depending on the OS family, whether it's Red Hat, so CentOS or something along those lines, or if it's Debian or Ubuntu, we're going to change the name. So if it's Red Hat, we know that that package needs to be named HTTPD. And if it's Debian, we know that it's got to be Apache 2. That's just the way that it is. And we're using Jinja to kind of run through this information and figure out what's going on. So in theory, this isn't really that complicated, right? When we look at it and see this single instance, we say, well, it's not really that complex, or it's not really that big of a problem. I understand what's going on here. But I'm sure the same thing happened in that data center where some guy said, we'll just run this one cable, and we'll just make this one cable from this rack to another rack. And then they just kept adding on to that, and eventually you get that mess on the right. And that's kind of the same thing that can happen when you're using a ton of Jinja inside of your states, or you're making things really complicated. You get this mess in the end. It makes it hard for people to understand, and especially new users. That's one of the big things that we want to try to bring people in, right? We want to get those new users so that they feel comfortable getting up to speed. And when you show an example that uses just a ton of Jinja and it's got all these pillar variables, it really gets frustrating and confusing to them, and it's really intimidating. So the next big thing for this complexity is pillar exploitation. I know people will be like, exploitation, isn't that a little much? But no, it really isn't. Because you see people really exploiting the idea of pillar and putting way too much stuff into either a single pillar or just doing terrible things. So we see a lot of OS variables going into pillar, which is understandable, because you might have different conf locations or something along those lines, but we really shouldn't be putting that data in there. It really doesn't belong inside of our pillars. We have the issue that pillars become really bloated. I don't know if anybody ever hangs out in the IRC, but we see a lot of the time people throw everything into their top pillar, even though you're not really supposed to do that. So we'll have things like, okay, we've got Apache inside of this top pillar. Now we've got our custom application inside of there. Okay, now we got PHP in there. And they're throwing this like 200-line top file at you for your pillar data. I'm going, dude, I don't have time to read through all this. Come on, break it out and make it a little easier for me to understand. And again, we come back to that idea that when you have a really bloated pillar like this, even if it's structured well, it's very intimidating for people who are new to your organization or who are new to the idea of Salt to really get in there and feel comfortable digging around and seeing what's going on. And that's something we really need to try to avoid, is that extra complexity that we don't need, right? If we can break it out for those users, then let's make sure we do that. It's not any more work for us, and Salt doesn't care, so there's no excuse not to. So when you combine the pillar and state complexity, what you really get is totally unacceptable, right? That was the only way that I could describe it when I was thinking about this, because you've got all this Jinja going on that adds onto it, and then you've got pillar data you're referencing, and trying to look at that as someone who is new to Salt, or just not really familiar with what you're doing, is really tough. It's really confusing to them to see what exactly is happening. So this complexity leads to a lot of problems, right? Most systems or most configurations are going to be OS agnostic. So this doesn't apply to everybody with the fact that you have different operating systems. I know in my environment that I have different operating systems. You guys may or you may not. But when we have those different operating systems, we have a lot of data that we have to figure out, right? Like, okay, the package is named differently, sure. Is the service named differently? What about the conf file location? Did that change between these two? Are the permissions different? All this kind of stuff you have to figure out and make sure that it's getting checked somewhere. And that can lead to a lot of extra issues. So we also run into multiple locations in a state. So I don't know if anybody else has ever used any other config management tools where you have requires, or you're using includes, the equivalent of includes. So you run into issues where you have a state that is going to require something else, right? It requires either an ID or, unfortunately, like the directly referenced name of the package. So when you require that stuff, if you change it, you're going to have to either grep through it and find all of those, or run a sed and change everything later, which is kind of a hassle. And again, it runs into that issue that it's very difficult for people who are new to your system to get up to date. And then we have several states that require changes. I did this all the time at my old job where we ran another config management system where I would change data inside of one file, and then I would try to do a run, and it would bomb out because, oh, I was using that data in another file. Okay, now I need to go and change it because it's referencing that information. So it's hard for us to kind of, A, visualize that as users, that we need to have that separation, and also it takes longer to debug and kind of track down what the problem is. So then the question really becomes, how do we address this? How do we address the issue of this overly complex idea, right? How do we make it really simple? We want to focus on ease of use. So not just for ourselves, we want to make it so that if our developers need to jump in, they can come in and help us. We can hand it off to junior admins. You don't want to be writing states forever. You want to write some awesome stuff. You don't want to make minor changes. And that's a really big idea to try and get across, right? Everybody should be able to jump in and kind of understand what's going on so we don't have any screw-ups later when we're doing a deployment. We want to make sure that it's really simple to modify multiple locations. That's a big deal to be able to really have that power to say, okay, I've changed this. I know that it's changed throughout my environment, or I know that it's changed throughout all of its dependencies. And then we want to make sure that this can be applied to existing configurations, because I don't care how cool what you're doing is if I have to rewrite everything, because no team is going to go for that, and no person is going to say, yeah, I've got 40 hours this week to rewrite everything that I already wrote. It's just not going to happen. We don't have that kind of bandwidth to make that occur. So enter the SALT formula, right? So the backstory on the SALT formula was back in 2013, Seth and Eric from the SALT Stack team were doing this DjangoCon presentation out in Chicago. And that was the first time that this idea of using formulas really came in. And when I saw that, I was blown away by it. I'm like, whoa, this is going to be really cool. This is going to make it a lot easier for me to understand what's going on. And we're going to kind of explore what chunks of that make it so interesting and make it so awesome. So SALT formulas themselves are really the evolution of SALT states. They're not so much a complete change from what you're already doing as they are an add-on or minor changes that make major improvements. And they're really easy to write because if you're writing states already, then you're already writing formulas. We're going to add a few things in, we're going to change a few things that you might have to go back and modify. But overall, if you can write a state, then you can write a formula. It's that simple. They are a little bit difficult to understand. Now, there's some great documentation out there. But when they were first coming out, it was really kind of challenging if you weren't a Jinja expert to see how things were working or how things were progressing. Okay, so first off, let's take a look at the formula directory structure, right? So we're going to use Apache throughout this as really the main example since I already wrote it above, and that just makes it easier on us to kind of transition through. So we've got our init.sls, right, which is going to drop on the server, it's going to drop on the packages. It's going to basically configure everything so that we're ready to at least get a very basic configuration going. So it's going to start our services and so on. And then I created this conf.sls because I want to manage my conf separately. I don't want to use the default Apache conf that comes with everything. I want my own. So I created that file. And then as you can see here, I have underlined the SRV Salt Apache map.jinja. Now the map.jinja is one of the core ideas of the formula. And that's why I underlined it, because it's important. So it's really a really fantastic idea, right? I mean, it was one of the things that really excited me more than almost anything else about formulas when I first saw what was going on. So what's really great about the map.jinja file is that it sets data based on OS grains, right? So when we're putting our information together, especially in OS agnostic systems where we have maybe, you're running Fedora and Debian, or you've got SUSE or some weird combination like that, the fact that it's setting this information based on the OS variables means that you're not setting those somewhere else, which is fantastic for those of us who have to change a lot of stuff up, or for those of us that are depending on others. It merges with pillar data. This is another thing that makes it really cool. So when you merge that pillar data together, the maps, they just work, right? You have your map in there, you can reference pillar, and it all goes into the pillar in the end, which makes it really simple to understand what's going on. And the best thing by far is the fact that we centralize variables. We no longer have the idea that we're going to be using a bunch of Jinja spread out through multiple states to kind of figure out what's going on. Instead, we're going to have this central location where everything is at for the OS-based stuff, where we just know that it's going to be there. So we can take a look at the Apache map, right? And when you look at this, the middle section there isn't really too difficult to understand, right? We know that we're going to be setting some variables. But the lines that really trip people up are the first line and the last line. So the first line, all it's doing is setting the Apache variable to some of these variables, right? Grains.filterBy by default, uses OS family when it does any kind of filtering. So we don't have to specify that information. So that first line is just saying, hey, set the Apache variable to some of these things. So we have, if it's a Debian machine, it's going to be apache.server is equal to Apache 2. Whereas if it's a Red Hat machine, it's going to be HTTPD. So it's really easy to understand what's kind of going on there and how that's getting set. And then we have the last line, which really confused me when I first started looking at these. And that's just saying, hey, merge all of this data into the pillar at this specific location, which is going to be Apache lookup. So underneath Apache lookup, that's where all of these variables are going to live. And that makes it really easy to understand where it's going to eventually go into the pillar data, as long as you kind of know what's going on there. So it's not that complicated once you kind of see what those top and bottom lines are doing, because the middle is just a bunch of assignment. Okay, so if we look at using the maps inside of state files, right, this is where, when I show this to people, this is where they kind of really clicks for them and they really understand what's going on. So you can see on this first line, right, we've got from Apache / map.jinja import Apache with context. So basically, we're just taking the context of that map file and importing that data in. So then when we get to the Apache section, we have the package, we install it, and instead of basing this information on a grain, right, on an OS variable, and having to put that inside of our state, we're simply referencing apache.server. So we've cut out, what, 2 lines, 3 lines there, and then at the end an end if. So we really cut down on that, and it's really cool when you look at this, or it was for me at least when I first saw this, to know exactly where that data is coming from. I don't question anymore, okay, well, is this variable getting set because of this Jinja content, or how does that get in there? I know that, oh, if I want to change these variables, where am I going to look? I'm going to look at my map.jinja. You know, it's not even a question at this point. You just know exactly where it's going to be. And it's the same thing for service. You know, it ensures the service is running, sets up the name, and then it enables it. And we're once again pulling that variable from our map file, which gives us a lot of power to understand what's going on. And that understanding is one of the really crucial things that formulas, you know, kind of create. That's really important to me as an end user and to somebody trying to teach others how to write formulas or how to write states. Okay, so if we look at before, you can see that I had to crunch this down, way down, in fact, to get it on there. For anybody camera-wise, it's just the same state we looked at, but with Jinja content. So I had to really crush this down because there's so much extra content going on in there. And then if you look at the after, this is what we just looked at, right? And when you see the comparison there, that's what's really cool. And the very first time that I saw this, that was the face that I made. You know, I was like, oh, that's sexy map. Because that's really the only way to describe it. I mean, when you're coming from seeing tons of Jinja variables or that terrible before, and then you see that after, you're just like, oh man, that is sexy. You know, it's just fantastic as an end user or somebody who's got to write a lot of that content, because you're reducing how much you have to write. You're making it so much easier to hand off. I mean, I can hand that to anybody, and they're like, well, where does this variable come from? Well, I don't know. Did you read that top line? If you did, then you're all set to go. So if we look at the idea of more maps and states, I added this as an example so that we could show that we don't just have the data coming from the map.jinja, right? We can use pillar data as well. We can pair them together to get a really great result. So again, we import that map.jinja at the top, and then everything's pretty similar, right? We have the Apache conf, which I went over a little bit earlier. You could see, you know, it's just the standard Apache conf location depending on the OS. But then in the source here, we have salt pillar.get, so we're going to be pulling some data out of pillar, Apache lookup config tmpl. Now you can see the first two sections there are really similar, right? We already looked at Apache lookup. That's where all of our map data is going. And I've simply got some nested stuff under there that's pulling the config and my template. So I'm able to define that information in pillar and just easily pull it in. So I just want to show an example where we're using both of them so there's no confusion about only one being available or something like that. Okay, so when we talked about complexity earlier, right, we talked about pillar and the fact that it can get really complex. People put way too much in the top file. They don't use the kind of structured idea of breaking things out. But formulas, that's a really key idea that we need to get across to end users and to other people in our organization, that they need to break out that data and they need to use that data in specific ways. So we're going to be splitting our pillar data into other pillars, basically. And we're going to be identifying it with sets of states. That's another really key thing about the idea of making formulas that makes them so fantastic, right? We have this constant identification. Where do I look for these variables that are OS-based? Oh, okay, I look in the map file because that's where it's getting pulled from. Hey, where do I look for these variables that are coming from pillar? I don't know, probably the pillar that has the same name or a similar name to what I'm doing, right? So that makes it very easy to kind of get into, to hand off to other people and say, yeah, this is what you need to do. Hey, can you figure it out? And if you put everything in one gigantic pillar, it's like, oh, maybe I can figure it out. But if you break that up and you say, this is clearly assigned to this or clearly defined as associated with this, it makes it really fantastic. And it's all going to be combined in the end anyways. All of this that we're doing is simply for readability's sake, right? Salt's just going to smash it together in the end. We don't have to worry about that, and it doesn't care. So when we look at a pillar directory structure, we're going to have our standard top.sls, right? This is something that everybody's going to have in their environment, unless you aren't using Pillar, of course. And then we have an apache.sls and a php.sls. Now the php.sls we're not going to look at. I just wanted to include it here so you could see kind of how that structure would look if we had multiple pillars that we were going to be putting into our top. Okay, so this is our new pillar.top, right? We had, let's pretend before that our top file unfortunately had both Apache and PHP content in there, right? It had all of our lookup data in there and everything that we might have set. Well, this is the new pillar top.sls, right? It's just a base environment, and every server is going to get Apache and PHP. It's not really that complicated. We didn't want to make it complicated in this instance. We wanted to make it simple and just keep things really low key. So when we look at kind of extending the pillar, right, this is going to be our apache.sls, right, that pillar file. And you can see we've got the same structure of Apache lookup. And if you pretend in your mind that you have the map data in there, it's all going to be right underneath this, or technically in the middle, where you're going to have all that information, right? The pillar is going to get merged in there. It's going to become part of it. So you're going to have all the map data. And then I have my config tmpl for Red Hat HTTP.conf. For some reason, I'm putting my Red Hat conf on Debian machines, so we can enjoy that not working correctly. But when we end up merging the maps with the pillar, right, this is a crucial thing to understand, that the maps are going to get merged with the pillar. I know that we showed that earlier in the map.jinja, but you really have to understand that it's going to happen regardless of what goes on because of how we've defined it. Now, technically, you could cut that out if you really wanted to and just leave that information inside of your map.jinja, but there's no reason to do so. So the multiple pillars, they really reduce that complexity, right? They make it a lot easier for us to kind of understand what's going on and to visualize it. That's always key. We want to visualize it as easily as we can when there's a setup like this. We want to make it easy to include several pillars in your top pillar, and it is, right? I mean, you're just putting dash and then the name of the state. That's all you're doing, and it makes it really easy. And then pillar variables can overwrite your map. This is one of the key things that makes the map-pillar relationship awesome, because if you have multiple people in your environment, right, you're using the same states for multiple groups in your organization. Maybe they just have a basic Apache, but you guys have some unique Apache that you've put together, and you need to overwrite that stuff. It's that easy to do. So if we needed to change the server, maybe you've compiled Apache with some weird modules that you had specifically, all we have to do is under Apache lookup, put server and then the name of your custom package or the path to it, and then it's going to install. You know, we're going to basically put in the name there so it gets pulled in. You might have to add a source if it was coming from a local location instead of a repository, but putting it in here overwrites that information automatically. So now our init.ssl is going to get that my custom Apache. And this could be split. You know, you could, instead of doing your base environment, have it in its own environment or some sort of configuration along those lines. But it's really powerful, and it's really fantastic to look at that and say, yeah, I can easily overwrite anything that's in the map file with a single line of code.
Can I ask a question now, or do you want to hold them to the end?
What's up?
Can I ask a question now, or do you want to hold them to
Well, no, we can go now. What's up?
I don't know if it's a Tom question or you. Where did the lookup thing come from? That's one thing that always confused me about this convention.
Like the Apache lookup?
Yeah, why did lookup get added as a value to your pillar tree? Why didn't it just go Apache config?
So the question was, why do we have Apache lookup in there?
Well, any of the formulas. Like, if you look at anything,
Yeah.
they all use that whatever, colon lookup.
You know, I think that was just kind of the standard. That's what Seth started doing originally when we had those. So it might be better to ask him that. I honestly don't know. I've just started doing that. Yeah, I've honestly just started doing it because I know that that's where it always lives.
Everyone else is doing it.
Yeah, everyone else is doing that. So, you know, why break from the
Well,
standard?
same thing. I follow the convention, but I'm like, I don't understand why we're not putting config right under Apache.
And you know, it might simply be because of the fact you might want other variables to live under Apache when you reference them inside your pillar, and you don't want to, you know, just get a ton of content in that first layer, because that might be problematic for some environments. I don't know if you've looked at some of the formulas, but there's a few that get really complicated, and they just have just these massive pillar files, and they're not even, you know, broken out. So to continue with that idea, right, we have these map files where we know everything lives. We have these pillar files which we know are named to be associated with data, right, with our states. And this really makes a lot of questions easy to answer. Like, oh, where did I miss that conf name change? We don't worry about that anymore because we know that it all lives in this centralized location. We don't have to worry about it being for a specific operating system, or did I include it in these multiple locations to overwrite that info? And we really avoid that, which I really like that part of it, just to try to avoid that redundancy. Did I make sure to update all my requires? Something that I'm sure has bit everybody at least once for other configuration management systems where you update that requires, it doesn't work correctly because it needs to be somewhere else as well, and then you just have to go back through and fix it. And we really avoid that, right? Because we're setting these names or we're setting these IDs. And if you're using IDs, it's not as big a deal. But if you're setting them directly as the name, you can really avoid a lot of problems. And then probably my favorite, hey, could you modify this value? Right, that's a question we want to ask to our junior admins, maybe to developers that are constantly working on our salt states, and just of other people on our team that maybe aren't as familiar with the specific state that we're referencing. And when we can do that and they can say, I think I can figure it out, that's something that's really powerful. It's a really great idea to try and get across to people. Okay, so the simpler we can make things, the better. That's kind of been the overarching idea here, right, is to simplify things, simplify things, simplify. So they're great even if you only have a single operating system. A question that comes up a lot is, hey, I only have one OS. Is this still worth doing? This seems like a waste of my time. And I'm never going to say, yeah, this is a waste of your time, because it still centralizes everything. We still have that central idea of where all this content lives, especially for the map, right? We don't have that check any longer. We don't have it hard-coded any longer. It's really easy to change on the fly, which is a fantastic thing to have. It's also really easy to hand off. I mean, you don't have to explain your 400-line pillar file to people when you break everything out. You don't have to explain where variables are getting pulled from when you're doing the map file and you have all that information available at your fingertips to simply reference. You know, you can just look through the directory tree. Where's anything related to Apache? Okay, here it is. I should probably take a look in there. And it also leads to fewer files to manage, right? Anytime when we can cut down on the number of states that we have to manage or the total amount of data we have to look at in any given day, I'm always a fan of that, so it really helps in that sense. So Bruce Lee said simplicity is the key to brilliance, right? As long as you don't make it too simple. That's one of an Albert Einstein style thing. So we really want to try to keep this idea of simplicity being one of our key steps that we have for people there, right? We want to make managing formulas really easy, and that's one of the fantastic things about formulas, that you don't have to waste a ton of time rewriting stuff. You don't have to waste a bunch of time figuring out a different structure, because the directory structure is the same as it's always been. We're just creating that map file. And there's only one of those map files per formula, right? There's just that one single item where you have all of your OS variables stored. And since the pillars are just included in your top pillar, all you're going to do if you're going to move to this kind of structure from a single top file is just cut and paste and put it in there, and then maybe change some, some names inside of that SLS to kind of modify how it's structured. But the work in the end is pretty minimal. I mean, you can set through, easily change any kind of variables, and dump that Jinja data out of there. Okay, so when we talk about creating a formula, we kind of went over this before, but it's something that's super easy to do, right? We have the map.jinja, and when we're trying to contribute this back to the community especially, we want to have an example pillar file, right? We want to make sure that we have an example out there for people to kind of see, how do I overwrite these variables that might have default set? How do I modify certain things? And that's really a fantastic idea. And this modular structure, right, that's kind of a key thing for states that a lot of people still aren't using, and we really want to emphasize that idea inside of formulas, right? We want it to be as modular as possible and as reusable as we can possibly make it. So when we're writing formulas, there's a couple things we need to think about to do so effectively, right? We want to think about what's going to be OS-based inside of our formulas, right? I talked earlier about, is it just going to be the name of the package and the service? Is it going to be the conf file? Okay, well, what about the conf file contents? Are those different between operating systems? I know for stuff like fail to ban, it totally is. But is it for everything? I don't know, and that's something that we need to explore. We also have to consider what might need to be expanded on, right? Either by other members of your organization or by other people you're sharing this formula with. You want to really think about that. Should I set some kind of variable for this item so that they can later change that info without having to do a ton of work? And we also want to look at, how is someone else going to use your formula, right? Is this going to fulfill the needs of other users in my organization and ensure that they can do what they need to if they want to mess around with this or they want to get up to speed with it? So here's where I kind of pimp out the SaltStack repo a little bit. We've slowly been kind of working on these for a while now, and there's about 90 on there currently, but only about 75 of those work correctly or are filled out. Some of them are still blank, but they're all publicly available. They're all under an Apache license. So if you want to use them, modify them, upload them to your own repo, you can do whatever you want, you know. Not all the formulas require the map file, right? We have things like nano. You know, it's just nano. There's nothing else that you're going to have to modify between systems for that. And it's really easy to just fork with Git. You know, if you have a GitHub account, you can fork it. You can always download the source directly, I think via zip if you want to do that. But it's really easy to get these and to get up to speed quickly. You know, there's stuff like Apache, there's Nginx up there, there's PHP, there's Perl. So we've got a bunch of them up there for people to really get up to speed quickly and to just be ready to build a system out and make the changes that they need to. Okay, so contributing back. This is a big one that I've been trying to push a lot in the IRC, if you ever hang out in there, is to try and get people to push back their formulas. Because we have a lot of guys contributing awesome stuff, but they don't push it back, right? They'll show you like a gist of it or something like that, but they don't push back to the repo because it's not done enough. It's not OS agnostic enough. It's not ready enough. Well, that's not a problem. I mean, we can always work with you to make it OS agnostic. We can always help you to get it ready. But if we don't have it up there and it doesn't exist for other users, then everybody's missing out. You know, I'd rather have something that doesn't work or is partially working that I can build off of than nothing. So if you want to contribute back, you can just fork one of the existing repos. You can always ask for a repo to be made. I think there's 13 people now who can make repos. We're usually in the IRC chat. We can make a repo for you. You can then fork it and then just do a pull request and we'll happily merge it back in. And you can always contact the members if you have questions, you know, the mailing list, IRC, that kind of stuff. It makes it really easy. You know, we try to help everybody out, obviously, to get up to speed and get ready with formulas. Okay, so that's pretty much it. I left a bunch of time here at the end because I wasn't sure if there were going to be a lot of questions for people who were moving towards formulas or thinking of that idea. So, I mean, if we have questions, more than happy to take the first question. Yeah.
You only used the example of basically doing a formula based off of OS, but what are some other, are there others? Is it best to do with things that are more going to be grains or whatever, or is it, what are other applications?
Okay, so the question was, I only based my map information off of OS grains, and is that the only way to do it? So technically the map should only be used for OS grains. That's the only thing you want to put in there. There's a couple of guys in the community who are experimenting with other files like a settings.sls, where they're basically treating that almost the same as the map file, right? They're just not merging it into Pillar. So instead they put all of their variables inside of that file, and then they just import it just like we did, and then they're using it from there. So technically the map is really only supposed to be used for OS stuff because we want to keep it really flexible for people to download and to pull down from us and to instantly be able to use, right? So that map file is really to make things simple to get up to speed with. All right. Next question? Yeah?
So you use the example of overwriting in Pillar a specific Apache customization.
Yep.
But that itself was not OS dependent. How would you,
Correct.
How would you manage a different Apache build for each OS?
So I mean, if you were going to do a different Apache build for each OS, you could use some Jinja templating if you wanted to. That's kind of a dirty workaround, of course. I'd really have to think about it, but yeah, I mean, you'd probably just end up having to use some Jinja inside of the Pillar, which is kind of a weird thing to do. I don't really like to do that. It might be one of those considerations where you have your own settings file, like I was talking about there, or maybe you even overwrite the map if it's just an internal project, and you just overwrite it yourself to use the two different options. So. Oh, and the question on that one was, what happens if you are trying to merge data into Pillar where you have multiple, let's say, different packages, one for Debian and one for Red Hat? So, does anybody else have any other questions? All right, I guess we're done.